Okay, this is a video for anyone who's on remote learning or who missed class and wasn't able to be in class for this stoichiometry guided introduction. The mole ratio is the relative, when we talk about a mole ratio within an equation, it's the relative amount of products slash reactants used. Let me show you, for example. First, we have this first equation. We have to balance it. And let's see, I can balance it by putting a 2 here and a 3 here. This equation is now balanced. Once I balance it, I see that my ratio of N2 to H2 is a 1 to 3 ratio, meaning for every one N2 molecule, because if there's no number, it's like there's a 1 there, I need 3 molecules of H2. For every one molecule of N2, I produce 2 molecules of NH3. And for every 3 molecules of H2, I produce 2 molecules of NH3. In other words, I use the coefficients, these numbers that I used when balancing the equation, that tells me the relative amount of the products and reactants used. And it's called a mole ratio because this relative amount is always discussed in moles. If I have 1 mole of N2, I need 3 moles of H2. If I have 1 mole of N2, I produce 2 moles of NH3. So these ratios are always talking about a relative amount of moles in a reaction. And that makes sense because moles is just a number of items. So when it comes to doing a mole to mole conversion, these boxes we're just going to use to do work if we have any work to do. It says number 1, how many moles of oxygen are produced when 3.0 moles
Hi,
of
folks.
potassium chlorate?
Today, I am going to teach you about the mole in chemistry.
That was random. How many moles? Okay, let's get back to here. How many moles of oxygen are produced when 3 moles of potassium chlorate decompose? So this is potassium chlorate right here. And it's going to decompose completely. And we want to know how many moles of oxygen are produced. Well, I start with my given, which is 3.0 moles of KClO3. And now, if I want to go from a mole of something to a mole of another thing, this is where I use my mole ratio. And I know that according to these numbers right here, for every 2 moles of KClO3, I will produce 3 moles of O2. So that in total, when I multiply 3 times 3 divided by 2, that's going to be 9 divided by 2. It ends up being 4.5 moles of O2. So what did I do there? I started with my given. I plugged in these 2 numbers right here as my mole ratio to say for every 2 moles of potassium chlorate, 3 moles of oxygen are produced. These cancel out. My final unit is moles of O2, and I did 3 times 3 divided by 2. 4.5 moles of oxygen are produced. That's going from moles to moles. Okay, if I wanted to do moles to grams, let's take a look at this one right here. With 12.00 moles of sodium chlorate, how many grams of oxygen will be produced? So it's the same thing. I'm going from moles, but this time instead of moles of oxygen, I want grams of oxygen. Let's do that. I'm going to start with my given. This is my given. This is what I'm looking for. I'm starting with my given 12.00 moles of NaClO3. And let me go ahead and zoom in here. And I know For every 2 mole, now if I have moles of NaClO3, moles of NaClO3 is going to go here. And I want grams of oxygen. And before I do that, I need to figure out moles of oxygen. I'm always going to go from mole to mole first. And I know I plug these numbers in here. For every 2 moles of NaClO3, I've got 3 moles of oxygen. And I'm not going to stop there because I want grams of O2. So moles of O2 is going to go on the bottom. And I know I'm going to go to grams of O2. And this I figure out with the molar mass. I know for every 1 mole, how many grams of O2 I have? Well, it's 2 oxygens. So it's 2 times the molar mass of oxygen, which is 15.999. I get this number from the periodic table. And if I add up 2 O's, let's see what that gives me. I have let's turn my TI on, 15.999 times 2. That gives me 31.998, and that's grams per mole of O2. So for every 1 mole of O2, I know that's going to be 31.998 grams. And that's what I'm looking for. All of these units will cancel out. I'm going to end up with grams of O2. How do I put this into the calculator? I do 12.00 times 3 divided, and I'm going to multiply the top. So times 31.998 divided by 2 divided by 1. And I'm going to round this to 2 decimal places. So my final answer is 575.96 grams of O2 is produced when this many moles of sodium chlorate decompose. This is my final answer for number 1. Finally, so grams per mole is the same thing, except I'm going to go backwards. I'm going to start from grams. I'm going to go from grams to moles. In fact, let me just set this up here. You're going to get a certain number of grams here. You're going to go, and in this first question, for example, it's grams of NaClO3. You're going to go from grams of NaClO3 to moles of NaClO3. And then you're going to go from moles of NaClO3 to moles of O2. This is how you do number 1. And remember, you add up the number of grams. This is from the periodic table, the molar mass. Molar mass. And here, this is my molar ratio. So this is going to be a 2-to-3 ratio. Finally, let's say I wanted to do a grams to gram conversion. So I start with this reaction, and they want to know how many grams of hydrogen are required to produce 145 grams of methane. Well, let's start with 145 grams of CH4. I'm going to go from grams of CH4 to grams of H2. I need to convert to moles because these molecules are going to react in terms of their number of molecules, not in terms of the number of grams. This is something we'll learn about in class through some labs. We always have to convert to moles. And so I'm going to go from grams of CH4 to moles of CH4. If I add up 1 C and 4 H's in the periodic table, its molar mass is about 16. So for every 16 grams of CH4, I have 1 mole. I'm going to draw another bunk bed because I'm not done. I want to go all the way to grams of H2. I need to go from moles of CH4 to moles of H2. And I know based on these numbers, this is my molar ratio here. For every 1 mole of CH4, I have 2 moles of H2. I'm not done yet because I want to go to grams of H2. So I'll go from moles of H2 to grams of H2. And for every 1 mole, I know I have about 2.018 grams of H2. And all of these units would cancel out. My final unit would be grams of H2. And I would multiply the tops and divide the bottoms just like earlier. And that would give me how many grams of H2 is required to produce 145 grams of CH4. I know that was fast, but what you can do is rewind this video, watch it slowly, and then check in with me in order to get some extra help.